Lesson 3. Using the SSS method to find congruent triangles. Chapter 10. Learn one of the ways to find congruent triangles. Learning goals for today. Understand the stability of triangles, master the SSS judgment of triangle congruence, and use it to determine whether two triangles are congruent. From the process of exploring the congruent conditions of triangles, experience the process of obtaining mathematical conclusions by operation and induction. So, last time we learned all about the definitions and properties of congruent triangles. And in this quick review, I want to quickly ask you, what is a congruent triangle? Or what are congruent triangles? The answer is that two triangles that can perfectly overlap is called congruent triangles. Remember, when we say perfectly overlap is when you put them on top of each other, their sizes are exactly the same, but their colors, what they look like, does not matter. It's just their size and their area. 2. What properties do congruent triangles have? Corresponding sides and angles of congruent triangles are congruent. 3. Given that triangle ABC, remember this sign? Given that triangle ABC is congruent to triangle DEF, find the corresponding sides and angles. So over here we have triangle ABC, and over here we have triangle DEF. So first, AB is equal to DE. Second, BC is equal to EF. CA is equal to FD. Angle A is equal to angle D. Angle B is equal to angle E, and angle C is equal to angle F. Two triangles with 3 equal sides and 3 equal angles are congruent triangles. Think, if only part of these conditions are met, can triangle ABC be congruent to triangle DEF, be guaranteed? So let me explain what this means for a minute. So it's saying two triangles with 3 sides that we know is equal to each other and 3 angles that we know is equal to each other has to be congruent triangles. Well, that's true because then every angle is congruent and every single side is congruent. Then that means the whole triangle, both of the triangles, are congruent. But only part of these conditions are told to us. Can this statement be guaranteed? Finding congruent triangles with the method of SSS. Exploration 1. What if only one line of information is given? Here is one line of information. One of the sides are equal. One of the angles are equal. So let's first just look at one of the sides are equal. So here we have two triangles with one of the sides are equal. But as you can see, that does not guarantee that these two triangles, the rest of the parts of the triangles, are going to be equal if only one of the sides are equal. And when they overlap, they are not congruent. But of course, can one of the sides be equal and the triangles can overlap perfectly? Yes. It's just that you can't guarantee that both of the triangles are equal. So it's not necessarily congruent. It could be congruent, but you can't guarantee it. Now let's look at 2. One of the angles are equal. So over here we see that there's 2 triangles, and one of their angles are equal, but they're not congruent. So the answer to this is also not necessarily congruent, but of course, can they be congruent at times? Yes, but not necessarily, not guaranteed. Conclusion. There is an equal condition that does not guarantee that 2 triangles are congruent. Exploration 2. What about 2? What about 2 pieces of information? There are 2 angles that are equal, or or there are two equal sides. Or 3, on each triangle there is one equal side and one equal angle. So there's two triangles and we know that one of their sides are equal and one of their angles are equal. That's 3. So for 1, we first have the triangle with one angle is 30 degrees and another angle is 60 degrees. And here we have yet another triangle who also has one angle of 30 degrees and another angle of 60 degrees, but it's slightly smaller than the first one. Now let's look at 2. There are two equal sides. First we have a triangle and one side is 3 centimeters long, another side is 4 centimeters long. Well, over here we have another triangle and one side is 3 centimeters long and the other side is 4 centimeters long as well, but they're not congruent. Now let's look at 3. On each triangle there's one equal side and one equal angle. So there's one angle that's 30 degrees and one side that's 6 centimeters. Well, here we have another triangle. It also has 30 degrees as the degree of one angle and 6 centimeters as the length of another side. But they're also not congruent. So these 3 are all not necessarily congruent. But of course, sometimes they can be congruent, but you can't be sure. It's not guaranteed. So the same conclusion for this is that there is an equal condition which does not guarantee that the triangles are congruent. Now what about exploration 3? What about 3 pieces of information? 1, there are 3 equal angles. So both of these triangles have one 90 degrees, one 30 degrees, and one 60 degrees. But one is larger than the other. And this is because of dilation. So this is also not necessarily guaranteed. Conclusion: triangles with 3 equal angles are not necessarily congruent. But what about there are 3 equal sides? So first we have this triangle. It has one side of 4 centimeters, one side of 6 centimeters, and one side of 3 centimeters. Here we have another triangle with the same lengths, another triangle with the same lengths. But as you can see, they're all just the same triangle. So this conclusion is that if there are 3 equal sides, then these 2 triangles have to be congruent. Now, let's do example 1. As shown, there is a triangular steel frame. AB is equal to AC. So let me mark the conditions as we read them. AB is equal to AC. AD connects to A and BC with midpoint D. So what does this mean? It means that BD is equal to DC because D is a midpoint right here. And it also means that AD is actually the angle bisector of angle A. So let's look at the solution. And right now we're trying to prove if triangle ABD is congruent to triangle ACD. So here's some problem solving ideas. First, we look for hidden conditions, which in this case that would be common side AD. Notice that AD is the shared side of triangle ABD and triangle ACD. Next, we find existing conditions. AB is equal to AC. Finally, we find the preparation conditions, which that would be BD is equal to CD or DC. So these 2 line segments are equal because D is the midpoint of BC. So here's the proof. D is the midpoint of BC, So BD is equal to DC. In triangle ABD and in triangle ACD, AB is equal to AC, that's given. BD is equal to CD, that's proved. And AD is equal to AD, that's the shared side. So triangle ABD is congruent to triangle ACD because of the method SSS, side, side, side. So here are the preparation conditions. This is the specified range, arrange the basis. Then we have the conclusion. Next, we have to prove if angle BAD is equal to angle CAD. We know that triangle ABD is already congruent to triangle ACD. Angle BAD has to be equal to angle CAD. The corresponding angles of congruent triangles are equal. So here's some training. As shown, C is the midpoint of BF. AD is equal to DC. AC is equal to DF. Prove if triangle ABC is congruent to triangle DCF. So C is the midpoint of BF. BC is equal to CF. AB is equal to DC. AB is equal to DC. AC is equal to DF. AC is equal to DF. Prove if triangle ABC is congruent to triangle DCF. Here's the solution. C is the midpoint of BF, which means that BC is equal to CF. And in triangle ABC and triangle DCF, AB is equal to DC, that's given. AC is equal to DF, that's also given. And BC is equal to DF, that's proved. So that means that triangle ABC is congruent to triangle DCF because of SSS. Now we're going to learn about the stability of a triangle. Do it yourself. First, I want you to gather seven pencils, 7 sticks, maybe 7 popsicle sticks, and then come back to your computer, your device, whatever you're watching this video. Do you have your supplies? Great. So we're going to be doing an activity together. First, what I want you to do is, you don't have to nail these together, just place them together into a triangular wooden frame. So take 3 wooden strips, or take 3 of those whatever sticks you have, and then place them into a triangular frame. Then take the remaining 4 wooden strips into a quadrilateral wooden frame. So just any quadrilateral. So please take a look. This is what yours might look like. Here are the triangle and quadrilateral models. If you twist the model, or if you kind of try to shift a little, will their shapes change? Is it wobbly? Well, for the triangle, it's not going to move. But for the quadrilateral, it will. It's going to tilt side to side. It's going to become diagonal. Discover that triangles have stability to their shapes, but quadrilaterals do not. When you try to move one of the sides after it's already nailed together in a triangle frame, it would not move. But quadrilaterals will. So look at some of the furniture around you. You might see that there are many triangles, or maybe there are quadrilaterals with a diagonal through it to make, say, a chair stable. That's because triangles have stability. So let's understand the stability of the triangle. As long as the length of the 3 sides of a triangle is fixed, the shape and size of the triangle are completely determined. This property of the triangle is called the stability of the triangle. That is to say, the stability of a triangle is not a problem of pullable and unmovable. The essence should be the shape and the side of the triangle are determined when the lengths of the triangle sides are determined. So what I want you to quickly scroll down on your notepad is that triangles have stability. Once the 3 sides are fixed, the shape and size of the triangle are completely also fixed. So that's something that's very special of the triangle, because it has stability. If you try to move it after it's already nailed together, it's not going to move, it's not going to change shape. It's just going to stay where it is. Class summary. Today we learned all about two triangles with all three sides that are equal will be congruent. The SSS proving method of the congruent triangle. Two triangles with sides of the exact same lengths are congruent. And the stability of the triangle. Once the sides of a triangle is set, the size of the whole triangle is set. Lesson summary. Here are the two skills we learned today. First skill. Understand the stability of triangles. Master the SSS judgment of triangle congruence and using it to determine whether two triangles are congruent. From the process of exploring the congruent conditions of triangles to experience the process of obtaining mathematical conclusions by operation and induction. That's the end of this lesson, and I'll see you next time.